Was good. Was busy between family and friends, and not everybody's at the same place. So as I was telling them, I kind of like almost did a full tour of France.
Oh, wow.
Not on your bike.
Not on my bike, no.
Oh,
As
okay.
a friend or car sharing.
Oh, wow. Were you driving like to move? And
Like for family trips, yes, but like otherwise was mostly train or car sharing.
oh, okay, I
Oh,
see.
in Europe. That's really cool.
Can you just drop it? Like, you don't have to bring it back, the car sharing stuff?
Oh, well, by car sharing, I mean like so actually like giving a lift to someone, like you have like it's bigger. It's in French. It's way bigger than Uber. Like you really register on that site that's called BlaBlaCar, and it's like so you have actually people. I'm a driver, and I have this rating, and I'm doing this. I'm doing these things between this and this, and and you can register as a passenger and try to find somebody that does the same thing as you.
Yeah.
And they share a lot like that.
And it's cheap.
And it's super cheap.
Nice.
Like you can go from, I mean, Paris, Marseille. It's like $30.
Oh, really?
Like even the train is close to 100.
Wow. Yeah, that's Shit.
I see.
Like how is that called in Quebec? Like there is like something amigo. So like.
I'm pretty sure I was gone by then.
Yeah, probably.
Yeah.
Yeah, so I didn't have like too much planned for today, but thought since the RFG conference is coming up in like what, 3 weeks?
Yeah,
something like that. It'd be worth just chatting about presentations and we can figure out what is needed and what we can help with, and maybe even do a dry run at them like in 2 weeks.
Yeah, that would be nice.
Yeah.
Oh.
I was thinking compressing just what we gave at GeoScience BC, right? The three talks into collapse it into one.
I think that actually is like entirely suitable.
Yeah.
Yeah.
I mean, your talk at the beginning was mostly on SimPEG, right?
Yeah.
And then just shortened a lot the case study. And
I would actually be tempted to go the other way.
Oh, yeah.
Because I feel like, I don't know, for an applied audience, most people aren't going to care about the code structure, really.
Okay.
They're going to care much more about like what it can do.
Application.
I mean, giving a bit of an overview is good, I think, but yeah, I think the application and then sort of just like, I don't know, the proof of the framework. So I think it was Soggy's example in there's like plots of the currents in DC, so showing actually how like the data are built up and things like that.
Yeah, people were into that.
People were stoked about that. Yeah. So I think like, I don't know, highlighting some of those things, especially like in terms of survey design, a lot of people were really excited about just being able to look at the currents. So I think stuff like that is probably going to be high.
Like who's the main audience? Is that the mostly mining people, or like what are the main application here?
It seemed pretty applied. I'm just going to pull up the website.
Yeah, not possibly mining, but really applied, yeah.
Hey, Devin. Yeah, and like looking at, even when we were first, we closed, is Eldad still in there? Okay. Like even when we were looking at the technical program and sort of the themes and stuff like that.
Mm-hmm.
Yeah, so here I can share my screen. Yeah.
Okay. It's pretty big. Okay. I see.
Yeah, so I think it's like pretty applied.
Yes, I like the Sajid talk that I gave in what was that? A couple months ago. There are some examples that you can reuse. I think I simply used the DC formalling to show the currents, and then a couple of inversion results. I used the L0 norm, show the like smooth inversion, sparse inversion, that type of stuff. So I think there's probably some stuff that you can reuse.
Would you mind firing me the link where it is?
Yeah. Oh, it's in the SimPEG SimPEG folder. I can send you a link.
Right. There's already a lot of stuff in the SimPEG folder.
It's big, yeah.
Yeah.
It's really cool. It's cool to like look back and see, I don't know, where things started, and also there's a lot of good stuff in there. Like in terms of was it when we were writing Doug's abstract for the keynote talk at the Airborne EM workshop, like just drawing stuff from previously written proposals, it makes it so much easier.
There's lots.
So yeah, it's good.
We'll need a glossary of some.
Yeah. It'd be cool to actually get like a website going for a lot of that stuff at some point.
Okay, just
Have that,
list them all out.
Yeah, and have it be a little more searchable. But
Yeah.
for
See
now,
what's in the folders.
Yeah.
Hopefully.
Yeah.
Yes.
And then you're giving a presentation.
Yeah.
Cool.
I have to work on that.
Yeah. Do you have a talk or do you have a poster?
I have a talk.
Okay, cool.
Yeah.
That's exciting. Yeah, do you have like a sketch of what that looks like, or do you want to chat through that at all, or are there things that we can help you with?
I guess as it's very applied, I'm really gonna build through my TKC example,
Okay.
like really not dive into the maths too much, like stay at a very high level of how I think about the problem and see how we gain at each step. And like, when we see with additional information.
Yeah.
Like so not too much on either the code or the math, but really like okay, we're able to. That's something we're able to do if you provide us with more data.
Yeah.
With if you take petrophysical data or you. And I'm just one thing I just want to add on that. I already ran a couple of tests. It's like adding borehole information too, and that will even constrain more like the shape of the very magnetic body at depth. So that's one that's the simulation I still need to run more, but will be like so that you complete the framework. Like you add petrophysical information, or you can add also geology like information.
Yeah.
So that's really like the way I'm gonna try to build that. Really like, okay, here is the gravity alone, here is the mag alone. We add the petrophysics for each alone, and then we do it all together, and then we add some borehole information and see the gain at each step.
Because in the lineup, I'm right before you.
Oh, nice.
Okay.
So I can set up the stage if you want in terms of like frame, for the SimPEG.
Okay.
We could line it up.
Oh, that's
more
pretty cool.
smoother.
That's very cool, because then I can say, so everything is developed in that framework. So
Yeah. It's like,
yeah,
That's nice.
that's pretty nice. Yeah,
so let's keep that in mind.
yeah. When we
Because that could be a really cool segue of like sort of showing what's done. Like a lot of the stuff that you'll be able to show are like things that are done in sort of the core framework.
Yeah. Okay.
And then
And
like
here's an
you can
extension.
segue a bit into like the research and development side of things.
Yes.
That's nice that that worked out.
Yeah.
Yeah.
Hopefully they keep it.
Yeah.
Keep it that way. But.
That's exciting.
So that's good. Yeah, I'll start working on it this week.
Yeah, sure. And then I don't know, maybe 2 weeks we can do
Yeah. That's for 2 weeks for sure.
like just flip through slides and do a bit of an overview. And I think Mike has a poster.
Yeah, I think so too.
So
Okay, we can
Yeah.
give also a shout out. Like, go check out the poster.
yeah.
Sag, what do you have to do for your chairing, man? I didn't hear back at all from these guys.
Oh, But I felt like I said I think he was okay. I don't exactly remember what was his name. Ian? I don't.
Is Ian.
Yeah. So he said like he's okay. Huh. Yeah, like not sure at the moment. Can you send him an email? Like I think I sent you.
No, I have it here. Yeah,
Right. Yeah, just.
I'll ask him. I'll ping him.
Yeah, I don't know. He said like at one point he's gonna introduce the main chair, who's more experienced. That's probably what he was supposed to do.
I imagine you'll just like have to show up, ask some decent questions. If
Yeah, I think that's probably it.
I can do that.
Perfect.
Are you guys ready for your EM?
we've got a bit of a sketch.
Well, like a half done, we sketch it. We got a plan. Need to do.
Yeah, so we'll need to assemble some stuff. I mean, thankfully from the disk, like the fundamentals section is done, and like a lot of the other stuff we can draw from.
Mm-hmm.
But it is going to take a bit to just like sit down and pull it all together. And then for our presentations, I mean, mine I think will be pretty straightforward. It's like a SimPEG e-talk plus looking at
Casing.
airborne. All airborne. So we did a 1D inversion. Well, we did a plate and then do some forward modeling, showing currents and stuff through time. I'm hoping actually we should follow up on this. I would like to use my own computer and actually have like a Jupyter notebook and be able to slide through time and things like that.
Oh yeah. It just depends on the format if they let you.
Yeah.
Laptop.
Yeah, I hope it's a small conference, and then I think it might be possible. It's not very it may not be very formal. That's similar to IP workshop before, but it was about 100 people.
And did presenters use their own laptops for that, Sagi?
You could, I think. I think it was I could.
I'll fire off an email and see if we can. Because if not, like you can always sort of do GIFs and stuff like that. But I feel like it's much more powerful to actually use the real thing.
Yeah.
Right.
Yeah.
Great.
Yeah. Cool. And then for your talk, Sagi, was there I don't know, are there things you want to chat about there? Do you feel like you've got a decent idea of what needs to be done?
For which talk?
Because you have an IP one, right?
No, I pulled out.
No, but at the Airborne EM workshop.
Oh yes. I haven't thought about that.
Yeah, fair enough.
Yeah, there we got the abstract, so I'm not sure how far I want to go, but probably just presenting that the what stuff in the abstract might be enough. I'm not sure that I want to do a bit more because there are lots of stuff for ducks.
Yeah.
And short course. So yeah, I probably just stay as it is that we have.
That's fair. And then one thing we should think about, I think especially for Doug's abstract, is they're going to do like full conference proceedings so we can publish a full paper with it. And so like you just take your abstract and expand it a bit.
Right.
I think for sure for Doug's one, we should do that. And then we can think about the other two. I think they were saying it would be due in September or something like that. So it's not too...
Yes, I thought so mine was mostly just a simulation paper. Using very similar approach for what Dave did, but using a little bit different approach. So I thought I might just do that.
Sorry, expand it to a paper?
Yeah. So that was my. I think I checked. I want to, because before you submit, you can check, right?
Yeah, but I don't think they necessarily hold you to that.
No, it's up to you. So why not?
Is there anything else you guys want to go over today, or?
Sagman, I see you pushing the EM1D branch. What's happening?
So Dieter helped a lot. So what happened? So I was using some of the. So the main thing for 1D code is a transformation, either from a kind of spatial frequency to space or frequency to time. So I think I've used in the beginning. I was using some of the scripts from Dave and probably some UBC alumni, and that wasn't it was accurate, but it wasn't designed very to be optimized in terms of speed. So I started using Dieter's code, some part, but not in a very good way. So Dieter took a look and suggested quite a few things where we could improve the speed. So yeah, so he actually changed it to EMPI mode. And then it was a couple of iterations between him and myself because he had to change his codes, like some of his code, to handle what's in SimPEG EM1D. So yeah, we went back and forth. I actually got the pretty optimized code, so it's pretty fast.
It's faster than before, really.
Yeah, it's much faster. So it wasn't too bad before, but now actually, yeah, I had to change the code quite a bit, but I think now it's actually more optimized. So I think pull latest branch and run it. I'm not sure how much is how much faster on your end, but I think at least for my testing, it's actually pretty fast. And I put the interpolation one, so at the end of the day, like you can interpolate 1D to 3D. So I think I put that in. I haven't hooked that up until not yet to GIF tools, but I'll do that.
Yeah, so I pushed the write to H5 now, like what we were talking about. So now instead of using the math file, you're using the H5, HGF file. So I guess we could interpolate before we transfer it, or
right. I think that's an option then.
Yeah, that's good. That's gonna be great, man.
What are you using for interpolation? Just like KD tree, or?
So this one is, well, like it's kind of weird interpolation because like you got a very sparse point in space if you think about like a number of sounding location or like airborne EM, and sometimes it's not aligned with your mesh. So just doing an interpolation doesn't do a good job. So if you do a simple linear interpolation, you're not going to get the good kind of, not sure what's good, but you're not going to get the smooth conductivity model. So what I had to do, I just interpolate in 2D first using KD tree. Here I could use like a inverse weight or whatever that you can make it your model in 2D space smooth. Then do a 1D interpolation to 3D. So first do a 2D in the XY space, then interpolate in Z.
Okay.
That's what I'm doing. Yeah. So like there probably some better way. I didn't know what's the better way. So I think if you do that, then you could make it smooth if you want, if that's the desired output. So that was what I was doing. I think it's pretty similar what you did, right?
Like, the opposite. It was a 1D first and then 2D, like the same, using the same weights in 2D. But actually, no, you're right, Doug. It was the same thing. Yeah, no, same thing. 2D and then 1D. Yeah. On my end, there's one thing that I still want to implement is to be able to see the models as they come out, or see the result as they come out. Don't have to wait till the end of the run. So we need to see if we can, like, if either we create like temporary H5 files, or if both MATLAB and Python can look at the same file. Like I have a listener in MATLAB or something that just keeps pinging the H5, and not have conflicts that they both look at the same thing at the same time. So I need to dive a little bit deeper. I haven't really spent time on it.
Yeah, I'm not sure. I'm not sure that you can see the same HDF5 at the same time. I'm not sure about that.
It looks like you can do sort of like lazy loading, but I'm just not sure if one is gonna start taking it's gonna lock the file while it's looking at it. I don't know if you can just or send a signal to one software to the other saying like, I'm looking at it now, wait for it, and then the other pings it, if they can alternate on it or something. Because it would be so much cleaner than having multiple H5 and flushing it at the end. That's kind of cumbersome.
Yeah, I have no idea, but that should be a straightforward thing to test.
Yeah, I think so, because that would be nice, right? Because we don't want to have the user to always wait till the end of the run. They might want to see the first few iterations and then kill it if it's not good.
Right.
So I will look into this next.
Sounds good. Yep.
Cool. And then the only other thing that we were chatting about before we went online here was discretize and pushing the octree code in. So the last thing I just wanted to connect with Joe on is I think there's some files in there that you compile with Python, and you should do that locally, so we don't need to be versioning them. But once we get that cleared up, I think we can pull that in and then just start using it. I mean, there's still some things missing, like plotting and stuff like that, but I think getting it in use and going from there would be a good thing.
Yeah.
So,
have you guys used that octree code?
Yeah. Craig is running it, man. He's going to run his first his like new data set over the volcano.
that's so awesome.
The mesh looks really nice, man, because it's so much topography, right? It's a
Oh wow! So do we have some like a mesh generator now?
Yeah, that's what I was going to tell you guys, is that we need to think. We have one, but right now it's only like one shot. It's one level, and we want, I think, like the same type of UVC as that we can say, I want like three of the next level and then 4 of the next level or whatnot, so we can like design a little bit better.
Yeah.
But then we need to operate differently if it's a cloud of points or if it's a line, if it's a line source. So yeah, we can sort of need like a smarter, way smarter mesh builder. I don't know if like the dictionary would work, if you say this, you're a surface and give like a sequence of numbers for the number of cells. If you guys have ideas, come talk to me and then we can brainstorm. You will need it pretty soon.
Yeah, that's a good.
It needs to be points. You need to give the code. Currently what Joe did is like some point location and then what octree level you want that point to be at.
Does the stuff that Rowan wrote, is that still work? Like the refinement around a
function.
Arbitrary function?
Yeah, but usually we don't work with functions, right? We're going to work with clouds.
Sure, but what we then can do is just basically like
parameterize it.
Yeah, write a wrapper that communicates this set of points as a function. So I think that's potentially a way to go, right? Is like given a set of points, how do you want to refine around those? So that is a function that then, or like class or however we want to structure that, that then communicates to the piece that Rowan wrote that just interpolates around or like refines around a function.
Okay.
Because all you have to do like for that refinement piece to work is like it just, I believe all it does is takes, like as long as you give it a set of points and say, or like
I have the feeling it takes the functions and it throws points in it. But
yeah, you have to actually put in a function handle. It's actually
right, but it doesn't have to be like a lambda function. It can be a function that like says true or false around or a refinement level around a set of points.
Oh, okay, but the cloud of points is really fast, works really well, right? Because his implementation, like finding a point inside a cell, is really fast.
That's fair, but I guess like for surfaces,
yeah,
there's nothing stopping us from turning that into a function. It doesn't have to be a mathematical function.
I see.
You know what I mean? It just has to be like, we just have to be able to say, given an XY location, should I refine yes or no? That's all that needs to do. So it doesn't have to be mathematical. It just has to be like a computational function.
Okay. That's one thing, but how do we after that decide? That's the issue, right? It's like, okay, let's say it's a surface. We only want to discretize the next level under. We don't want necessarily to go over. And then the points, it's all around it. A line is just along the axis of the line. They're all kind of different cases.
Right. So then we write like a simple wrapper that deals with those cases. So you say, I've got a line, so I'm going to feed my refinement this line. My surface will feed it that.
And then give different levels.
Yeah. Yeah, I mean, because that's the biggest things, right? Is points, lines, and surfaces. Once we have those,
you have everything.
You've got everything. So I think if we write something general, well, points is already basically done. So just lines and surfaces. And that should take care of that.
But the function, okay, sorry.
Well, no, there's the volume too. So a lot of times you put in what is your core region, at least for the way that the GeoSci codes.
Yeah.
That's true too.
Yeah, so then lines, surfaces, volumes.
anyway, yeah, that's something that we should push a little bit. Because I think even if you provide a function, this is just going to break to the finest level on the function, but there's nothing to tell it to how fast it's gonna expand out. Kind of need to feed another function parallel with a different octree level.
I think there should be some parameters in there. We can take a look. It's been a while since I've looked at that code.
Yeah.
I just am picturing the examples that are in the docs, and I thought there was some specifics around how many cells you want at that level.
Outside, okay. Or if they do, then it would be optimal. Okay.
Yeah, but I don't remember offhand, so we can take a look.
Okay.
So how currently you're using basically passing the points.
Yeah.
That defines that points into the a maximum, the smallest octree level. Is that the?
Yeah, that's right. And we would like to be able to control how many of maybe the smallest and the two other levels above, how far they extend out.
Mm-hmm. I see. I see. Yeah, have you guys used in the Jupyter Notebook?
If we use the Jupyter Notebook, what do you mean?
Have you used the discretized package, like an octree one, in the Jupyter Notebook?
Yes.
Oh, really? Okay. Yeah, because I found I used to use a tab completion.
Oh no, it crashes. Yeah, for sure.
So, okay, so that's not just my problem. I was just curious. What's happening here?
Okay.
I tried Spider. It's been worse.
Okay.
Well, you can make a note of that. Is that documented in the pull request?
Joe knows.
Joe knows. Okay.
Yeah.
So what's happening with that
The
completion?
kernel crashes if you try to use
So
tab.
don't use the tab completion. Then kernel dies. So
Yeah.
on your tree snapshot.
Okay, but I never heard that type of issue before, so I was wondering if you had an idea what was causing that. No.
There's not even an error log that comes out and
Just
the
dies.
kernel dies, so it's really hard to. But yeah.
Is that because of the C code?
Probably.
It probably tries to access a function that doesn't live in Python. I don't know. Yeah, I'm not too sure.
Yeah.
Joe knows,
Okay.
Okay, yeah.
but it shouldn't stop us to use it anyway.
there's no problem, right? It's a little annoying.
Yeah, we're used to something.
Yeah. Well, and it's motivation to get it working again. You get annoyed enough by it, we'll figure out how to fix it.
Exactly.
So. Cool. Yeah. Okay. So we'll look into the refinement stuff and see what can
What's
be done.
already there?
Yeah. Cool. Anything else on your end, Sagi?
Not really. I'm pretty good.
Cool.
Oh, it's good. Yeah.
Sounds good.
Early meeting.
Yes, really.
Yeah.
Cool. I'm not here next week, so we can figure out what you guys want to do, what would be beneficial.
I won't be here either in
Okay.
Montreal.
Oh, okay.
Okay. Well, then maybe we can postpone it unless there's something that comes up.
Yeah.
Or if you guys want to practice a presentation or something like that, then great. But if not, then
I will meet for
regroup
the week after.
in 2 weeks.
Perfect. Yeah, let's meet again for them and practice those
Yeah.
RFGs or go over the RFGs.
Yeah, that sounds good.
Excellent.
Wonderful. All right. See you later, Sagi.
Hey guys, I'll see you guys later.
Have a good day.